I'm Phil, VP of Professional Services at Intelitech. I've been involved in a number of container deployments and Kubernetes deployments over the last few years. And Joseph.
I'm Joseph Riddle. I've been using Docker and Docker Compose for the last year or so on a project I'm on, and soon to be using some Kubernetes as well. I'm itching, as we discussed earlier, to get Kubernetes working.
Yes. Cheers. All right. So tonight, given that our last session was Containers 101, this will end up being a Kubernetes 101, more or less. We'll start with a brief intro overview to level set, and then do some sample deployments. There's a lot of ground to cover here. There's a lot of ways to do deployments. There's a lot of feature and functionality in Kubernetes related to deployments. In the interest of time and scoping, we're only going to take it so far. And again, as I mentioned before we were recording, we rebuilt the cluster a couple of hours ago with all our demos on it. So we didn't quite get to getting everything back up and running. So it's the way it goes sometimes. If you're going to have a cluster die, it might as well be a couple hours before you're going to use it to do some demos. So Kubernetes, again, I'm sure a number of you have heard of it. Hard to imagine that you showed up and hadn't heard of it, and probably have some familiarity with it. So Kubernetes is container orchestration. So we have these containers. We have a number of containers. How do we reliably run them? How do we effectively manage them, efficiently manage them? Make sure that they're up without having to write a bunch of custom code and et cetera, et cetera. That's really what Kubernetes is all about. Managing containers. The implication is microservices, but what is microservice? It's a bit subjective. We're really talking about containers and what runs in containers. We're not really talking tonight necessarily about how one might divide up containers or divide up microservices or anything else. Just talking about the infrastructure of Kubernetes itself. There are implications with the way Kubernetes works, with the way you might want to design your containers. But again, topic for another day, more than likely, and perhaps some of our other meetup groups. So some of the key things about Kubernetes, it's orchestrating. So we give Kubernetes some commands. We give Kubernetes some configuration. It will deploy our containers, make sure that they're up and running. It can auto scale them. So we might start with one, and when load hits, we'll scale up. It'll watch container health. Container crashes, container dies. Kubernetes will spin it back up again. There's a number of security features baked in, and then also add-ons with the various providers that have the various providers that are providing Kubernetes services. A lot of networking options, and et cetera. So again, brief intro, overview, sample deployments. I probably covered some of the overview already here. So architecture, what does this thing look like? I mean, at the end of the day, or at the beginning of the day, whatever, Kubernetes is several VMs running services. Those VMs have container support, Docker container support. There's been evolving container support over the years, so it might not specifically be Docker, but we have a bunch of VMs with containers, and we have management services that are built into these VMs so that we can run our cluster. We can run a cluster, a group of machines, a group of nodes, and do interesting things. So this is a diagram right out of the Kubernetes docs. And it does a nice job of laying out some of the key components of what is in Kubernetes. If we start at the sort of the top here. If Kubernetes is being provided by a cloud provider or any provider, they're typically going to provide access to an API endpoint. Everything in Kubernetes is done through an API endpoint, and there's an appropriate server that's within what Kubernetes calls its control plane. over here. I can't track my mouse right now, but this is where the control plane is. This is a bunch of services that are running in a VM, or typically a set of VMs to manage manage a cluster. They include things like scheduler. So a scheduler is going to say, hey, take commands or understand that you want these containers run. It'll schedule them on nodes. You want to replace the containers. It'll schedule the replacements of the containers. It'll do things like pack the containers appropriately on your nodes so that you have the appropriate amount of utilization in your nodes, and you don't have to scale nodes too early. There's also a service called etcd, which is a key value store. These are things that your containers can use. These things can be secret. It's persistence. It's stored, easy to use. So it's a supporting service for the service. There's also managers, controller manager, which will include things like monitoring the health or getting responses, or getting the response from health probes to determine, are your containers healthy, are your nodes healthy, and if they aren't, take the appropriate action. The nodes here, this is Kubernetes talk, are VMs. Each VM in a cluster, it's going to have container support on it, but it's also going to have a couple of services that are pre-installed on the VM. You don't see them, you don't worry about them typically, unless you're trying to figure out why your cluster died, but that's another story. Or why your nodes died. Specifically, what happens is a node that we had earlier today just stopped responding. But in any event, there's a kubelet running, which provides basic services, such as, is the ability to talk, are the containers healthy? When the nodes spin up with the kubelet, what they do is they phone home to the API, from kubelet to API, and they tell the cluster manager, hey, I'm up, I'm ready to receive your commands to deploy containers. And whatever is involved in deploying a container, such as go pull this container from this registry and spin it up. And oh, by the way, spin up 3 of these if you so desire. And then kproxy is basically just networking proxies. So there's a virtual network within the cluster here so that containers can talk to each other, and containers on different nodes can talk to each other if you want them to. Because there's also network management and security management built into this, so you can take control over what can talk to who can talk to what, and et cetera, et cetera. Okay, high level overview. Make sense? Clear as mud? You guys knew this already? Keep going, Phil.
So for me, coming from more of just a Docker and Docker Compose background, more familiar with containers, there's also this concept of pods, which are like
pods,
a wrapper of a container. Where does the pod fit into the architecture overview?
Glad you asked. I'll get to that in 2 slides.
Right on.
So we're going to be demoing Kubernetes, Azure Kubernetes Service tonight, or AKS. We could have easily picked another one, but this is basically a hosted service for hosted service by Azure. Again, probably have heard of it. There's similar services. We'll do a little bit of canvassing later on, so I'm just going to move on. But basically, in AKS, what they've done is they're deploying virtual machines in their infrastructure. Again, you don't see them. You see whatever AKS decides to deploy or decides to expose, which is that API server. You don't directly see the scheduler, but you can interact with it. You can interact with etcd, which is that storage, the controller manager, et cetera. But that's all managed by Azure. They host that for you. They don't charge you for it because you spin up nodes, which are compute VM scale sets, Azure VM scale sets, and that's where you start to spin VMs and start to spend some money. And again, the architecture is exactly the same. Otherwise, there's kubelet, there's kproxy on each node that you spin up, which again is a VM. A node is the same thing as a VM. It just has these additional services running on it. And then you have your container runtime, AKA Docker, or again, I don't think it's specifically Docker, but what equates to Docker. And then your containers will run in there. What Joseph was talking about was a pod. Effectively, a pod is a grouping of one or more containers. Typically, it's one container, but there are reasons why you would have more than one container in a pod. And we could probably talk about that next. So we talked about nodes. Nodes are VMs. Within a node, you're going to have this virtual machine. You're going to have Linux. There are Windows server nodes, but unless you really want them or need them for some reason, for example, you're running some legacy application that requires VMs. Try not to worry about it. It's a lot. There's just the state of the art is not as evolved with Windows running Azure Docker hosts. It is doable. It is possible, but we don't ever do it. And haven't been asked to do it that I'm aware of. I don't know everything, but I don't think so. So in any event, we have this node, which is a VM, Linux, kubelet, kubeproxy, and then we have what Kubernetes calls pods. And again, a pod is a wrapper around your container. So it's not just the container itself, but there's also some attributes or context that pod is going to run in. Key labels, what its name is, various things that you can do, that you'll need if you have more complex deployments. Many containers, many different services, and et cetera, et cetera. And again, you can also have a pod with more than one container. General rule of thumb is one container, but there are reasons why. For example, you have two containers and there's a lot of traffic between those containers. You can leverage, for example, I don't know, image processing, and maybe you want to pass the image in between two different containers. There's high degree of traffic. That might be one reason to put two containers in one pod. Be careful with this, because what this does, the minimum scale unit of a logical scale unit of a Kubernetes cluster is going to be a pod. So if I want another container 3, if I want a second container 3 running to manage my load, I'm also going to get a container 4 along for the ride. Whereas if I've got things split up, like in container 1 and container 2, I can scale container 1 independently of container 2. Container 1 might talk to container 2. Container 1 might be a web front end. Container 2 might be business logic, API server, something like that. It's not getting hit as much as my web server, so I only need one of them, but I might want 3 container 1s. So those are, again, basic idea. I'm demonstrating node 1, node 2 here. You can have, hundreds, thousands of nodes in a cluster. There are limits. I don't know what they are off the top of my head, but it's a lot. Okay, how are we doing so far? Making sense?
Making sense.
Questions?
I don't see any questions in the chat.
Good. Thumbs up, thumbs down. Speed it up. I don't know if there's a little emoji to. I don't know if I could go any faster. Tend to move pretty quickly. Okay, so why Kubernetes? What are the benefits? I think this summary of some of the discussions, and this certainly is a definitive list, but key point is I can scale from 1 to 10s to thousands. So if I have a workload that scales or needs scale, most times of the week it's running on 1, and then maybe on Fridays I need 10s or thousands, something like that. Or during the day, 9 to 5 or normal business hours, I need 3, 5, 10 tens of containers or even nodes. But at night, things quiet down and I can run my load on 1. So I'm making effective use of my compute resource. I don't really have to worry about that, right? This is built into the platform. Or worry too much about it. I don't have to worry isn't completely taken away from you, but you don't have to worry too much about it. You don't have to write scripts and monitor events and all this other kind of stuff, because Kubernetes is doing it for you. Again, there's models here which are highly available, highly reliable. Even in the case of one container, I deploy one container. If that thing dies or gets, fails a health check or health probe, Kubernetes will restart the thing for me without me even having to think about it. The framework here is quite extensible and quite pluggable. I mean, everything is API driven. There are wrappers for the APIs. So you're not always having to call the APIs, command lines, et cetera. But there's quite a bit you can do with it pretty easily. Write your own extensions, and then vendor and community provided plugins and images are, there's too many to mention. And there's sort of the downside of this is, if you're looking for you can implement a service mesh, right? So we talked about all these containers that can run across a cluster. There's ways to segment these things into namespaces. If you do a search for Kubernetes service meshes, there's probably 100 of them, or 200, or I don't even know how many. I don't want to think about it. So it's like, well, which one do you want to use? I don't know. There are a couple of popular ones. Istio is the one that most people use, but there are dozens of others. So, and then again, the vendors themselves, various vendors will have plugins and make it easy to use their services. This would include the cloud providers and things like Elastic. There's a couple of other add-ins, Elk for logging and et cetera. You can just, point click, bang zoom. You can, put in Elk stack to do your logging and manage your logging and fire off alerts and build up dashboards and et cetera with Kubernetes pretty easily.
So we have one question in the chat, Phil. How to plan the size of underlying instances running the pod or pods? So maybe in other words, like plan the size of the VMs, like the nodes that are running all the different pods.
Yes, yeah, I think part art and part science. So this stuff tends to be pretty efficient. It's obviously going to depend on how your application runs. But with the monitoring that's available, you can put something up in a test environment, hit it a bit, and see what sort of utilization you get, and sort of decide what you want to do. And then you can decide, basically, there's like two strategies here, like start small and scale it up as you need to, or start medium and scale it down if it ends up being too big, or scale it up. Now, there's a couple of tricks here because the nodes themselves, they are dynamic. You can, horizontally scale your nodes. And Joseph, you had when we were sort of pre-planning, you had the same sort of questions, like, oh, why don't I just have one node with a zillion containers on it? Legitimate question. Well, if that node happens to die, the whole thing goes away.
Yeah.
Right. Versus something that's really tiny, and am I going to need to? I'm only going to be able to run a couple of containers on that node. Now you're paying for the VM when that VM spins up. Doesn't matter what it's doing, you're paying for it. If the VM isn't there, it's not running, you're not paying for it. Doesn't matter how many containers are on. Doesn't matter whether the CPU is hot or cold. You're paying for it. In the typical, again, I say that, and there are of course conditions and caveats, because there's shared compute that you are actually able to start using with some of the cloud vendors and Kubernetes. Early versions of Kubernetes is like, nope, you're stuck with whatever we give you, and you're going to manually scale it. But these days, you can use some of the shared compute, which is kind of a cool little option.
So you can have a VM that other people are using and maybe pay less for it if you have a smaller workload or something like that.
Yeah, or it's not, it's not as demanding. Like you don't care if you scale up. I mean, there's so many combinations. But yes, is the quick answer. So the thing to watch out for is that there are what you'll have are node pools. So I'm going to declare a node pool, and that node pool is going to have characteristics driven by whatever my platform provides. number of cores, amount of RAM, and every node in that pool is going to be a copy of whatever I decide that's going to be. So I might say, hey, I only need a half a gig and 8 cores, and that's good enough for me for one node, and I can handle the cost of one of those running, and I'm okay if I duplicate that and start up a second one, a third one, a fourth one. And then I might have a second node pool. I mean, the easy example is I've got a GPU workload. So I might need to do some AI, machine learning, something that I want to use a GPU for. I don't normally need that for my business applications, but this one machine learning workload needs GPU. So I'm going to dedicate it to the GPU workload, and I can prevent other people from using it because heck, the GPU is going to be expensive, right? The point being that I can relatively easily switch, but I've got to spin up and define another node pool that's going to take the workload on. So it's not hard. You just have to do some things. It's not going to happen for you automatically. So hopefully that answers the question without answering it too much.
Jumping in here, looking at the first bullet point, easy to scale from 1 to 10s to thousands quickly. Would hypothetically the world's largest 3-on-3 basketball tournament, where it's really popular for like 1 week during the year, and the rest of the year no one really talks about it, would that maybe be a good use of something like Kubernetes?
That would be a good use if the application that runs the site was built with containers. If
it wasn't,
it wasn't. It's been around a long time. And I mean, that particular tournament is a very interesting case study into and of itself. We actually have a white paper on this on the website, but currently the technical answer is it's using Azure App Service and Azure SQL and a couple other components behind the scenes. But just as you say, whatever, 350 days of the year, it's running, one instance and low DTU, which is the Azure SQL Server Scale Unit, and nobody's hitting it and nobody's doing anything. And then they open up registration, kaboom. So
everyone's using it.
Everyone's using it. We scale up multiple sites, and a lot of this is auto scale. I think when it started, but it's the same basic concept. What's interesting is that under the covers, Microsoft uses, I don't know if it's specifically Azure Service Fabric, but it's the same sort of thing as Azure Service Fabric, which isn't really container orchestration, but it's close. It's, service orchestration and et cetera. And it tried to be Kubernetes, Azure Service Fabric did, but it's really more of a cloud scale programming model or development model than just containers. Than just containers or container orchestration. In that sense, Kubernetes is a little simpler in some ways. And you build containers and deploy them, whereas with Azure Service Fabric, you're building services that are Service Fabric services, so you're tied to Service Fabric.
Gotcha.
Now, and again, this is actually on a later slide, so this isn't extra content, although it might turn out to be. I got to keep moving. Ultimately, the point is Microsoft, in their infinite wisdom, called it Azure Service Fabric. So everybody thought, oh, you have to deploy it to Azure. It's open source. You can deploy it anywhere the heck you want. And in fact, in the early days of Service Fabric, it was deployed on-prem on machines. And it's basically what Microsoft used, color in the lines. This is a high level, just go with me on this. That's effectively the service framework that Azure uses to provide Azure services. So, very interesting, very cool stuff. Guaranteed there's books about the story. Interestingly, counterpoint, Kubernetes was developed primarily by Brendan Burns at Google to help Google scale not just the the search. I don't know that specifically Kubernetes in its current incantation is really used for their search and their ad management. I think that's all sort of special stuff. But what he did is he took that out and took some of the key concepts out and built up Kubernetes for Google, primarily for Google Cloud Platform, and a lot of things they're doing in Google Cloud Platform. So that's sort of the story. And again, there's books written about that as well. So we don't have time for that. I think I've already blown my budget on time for what Kubernetes is and does. So some of the key things about Kubernetes, we talked about etcd. You describe your deployment. So I'm going to deploy containers. I describe them in code. Containers has a Docker file that you're going to use to describe your container. There's a YAML file which will describe my deployment manifest and the various things, attributes, and et cetera. And we'll take a look at a few examples in a minute. Again, we talked about the scheduler, provision pods is needed, monitors to scale, restart. So built into the platform, it can detect, hey, we're under load here. I'm going to scale your containers, and I can give it a min and a max. Or we're under load here. I'm going to scale your nodes because I need more nodes to deploy the more containers that you have. You can also hook this. I talked about it being extensible. One of our customers, for example, they're manufacturing, and they take images out of their machines. It's high-tech manufacturing, and they take snapshots or some image sort of data. I don't know exactly what it is, but it's high volume processing with GPUs. And the way their app works is they fill in queues for jobs that need to be filling up. Again, this happens to be AKS. We have other stuff on AWS, but anyway, this happens to be AWS. So they're putting in messages on Service Bus. They actually wrote, and I think eventually Azure built this in, but originally when it was built in, they had to write the monitor themselves. Instead of looking at, hey, is my pod under load or are my VMs under load? That was too late for them because everything would get swamped and wouldn't be able to keep up with the load. They're actually looking at early in the process, they're starting to get a high rate of things getting entered into a queue. And they're like, oh crap, we've got load coming. So we're going to spin up now so we can anticipate and be ready to roll when this stuff gets to the other end of the queue. So those sorts of things are possible. There's a lot built in, but if you need to go farther, you can go farther. And again, with this scheduling and monitoring, you're able to do 100% uptime deployments sort of built into the platform. Again, you don't have to go crazy with logic, with pipelines, with anything else. You can just say, hey, I want you to do a rolling deployment. I want you to do a canary deployment. I'm going to deploy to one machine, and then when this machine, or deploy to one pod, when this pod meets a health metric that you define, okay, the canary's still alive, it hasn't died, so now go ahead and continue the rollout and the deployment. Okay, keep going. So some scenarios where we have personally seen this used, they talk about the high-tech manufacturing, customer extranet, where the very large customer with retail outlets, and then they sell stuff to their retail outlets. So they're independently owned and operated. You probably heard that language before. So independently owned and operated, but you got to buy the store management stuff from the mothership. That's an example. Thousands of stores. Website, extranet, sales, airport management. These folks actually deliver services to airports. They're a consortium. They're actually an independent company, which is a consortium of various people in the airline industry. They do status displays, et cetera, et cetera. What they're actually doing is deploying a couple of clusters per airport. So they've got hundreds, thousands of clusters that they're deploying. Azure machine learning. So built into Azure, you can develop a model, train a model, et cetera. When you're ready to deploy that model, one of your options is to give it to Kubernetes. So Azure ML will build up the container for you, containers with the business logic and an API. So you can hit the machine learning model, and then you can deploy it into containers to scale it. Rental property management, I've got another diagram on that. High tech management we talked about. This is actually the rental property. So what these folks do is they provide a software as a service to corporations, companies that own buildings, and then they provide a portal to people who rent. So I want to pay my monthly rent. I've got an account. I want to set up auto pay, whatever. These folks private label software as a service to these rental outfits. There's a lot more property management that goes along with it. So again, they're another high volume, high peak sort of scenario. So most days of the week, other than the occasional maintenance request or something like that might come in, nobody cares about the friggin' rental portal that the apartment has provided. But when it comes time to pay the rent, you hit the site, make your payment. Might be an auto pay, which would be the same services, but driven by an API or whatever. So they have this highly massive scale sort of a problem and a number of issues, and they're using Kubernetes. We ended up putting together, so what's interesting here is, Kubernetes itself, highly available, but hey, what if the network to the Kubernetes goes down? Or what if, Active Directory, where I'm doing some authentication, goes down? Not that that would ever happen. Or not that, networks would ever go out. So, they actually, so you think about it, hey, all the scalability, but there's scalability on top of the scalability, or reliability on top of the reliability that you have to consider, if a region goes down, or if a management zone, a region goes down. Availability zone, thank you. I was going to get there eventually. The other things this shows is that, again, Kubernetes, you can do stateful services in Kubernetes, but really you want to do stateless. So how do you manage state, right? You're going to have to connect either your pods to static storage, or you're going to have to connect your pod to some sort of static storage. You can mount drives and et cetera. It really depends on what your need is. This shows a scenario where they're connecting to Key Vault to manage the myriad of secrets that they need, SignalR, SQL Server, Cosmos DB, based on the various services that they're using. And on the front end, they're using a built-in ingress controller to manage the traffic within a Kubernetes cluster, Azure Traffic Manager to which will automatically handle for you. Hey, I'm not able to access the East region. I'll take East traffic and route it to the West region. So, handling that sort of a scenario. And then they have DNS certificates and et cetera services outside of that for hitting. So it's an interesting case. Okay. Ways to do Kubernetes, many ways to do Kubernetes. Joseph is going to do a demo of Docker for Windows, which actually includes a small Kubernetes service inside of it. You're not going to scale nodes or additional VMs, et cetera, with that Kubernetes, but you can play with it, deploy, test, et cetera, locally. There's also a open source project, Minikube, that is a small version, something that you can deploy on your own. And we're going to talk Azure Kubernetes. AWS has one. Google has one. There's a product out there called OpenShift, Apache OpenShift, and this is actually a wrapper around the Kubernetes with additional features and functions for enterprises. The school of thought there is I'm going to put up a cluster, and then I'm going to have multiple different groups, independent groups that want to do containers, share a cluster, leveraging and maximizing VMs that I've got. And there's a new thing that I just heard about recently, Rancher. So if I think about the airport folks, where they have hundreds or potentially thousands of clusters that they're going to manage, something like Rancher is management on top of the management layer, management on management on management. Okay. Or you can deploy your own hardware on Raspberry Pis if you want. So there's some nice, there's some fun, YouTube and repos, GitHub repos out there that talk about deploying a cluster on Raspberry Pis. Okay, sample deployments. So I'm going to go through a couple of things here quickly, then hand it over to Joseph for a bit.
JT says K3s represent.
Absolutely. Yeah, it's all over the place. I mean, there are so many, and there's a long history here too, because there were some popular container cloud platforms or emerging cloud platforms that just kind of got pushed aside by this activity of the activity of the major three players, Azure, Google, and AWS. Although if you ask IBM, they'll say they're the biggest cloud provider in the world, and they may well be because they have cloud-based mainframes, or cloud available mainframes. Okay, so where was I? I was talking about, so what I did, again, I'm using a pretty simple deployment of Kubernetes, and it's really just a few commands to get going. I'm using the AZ command line. Again, I'm not going to walk through every one of these commands because it's, we're not here to talk about creating a cluster. We're talking about deploying to a cluster. But just to let you know, and I am posting this to a repo just so you know what I've done. I create a cluster. Key component is I have a cluster. I also have a container registry. While I'm here, I might as well put a C in container. So my containers, the containers that I build anyway, I'm going to put into a container registry. They don't have to build, they have to go into this container registry. This container registry would be for things like private containers, things that I don't want to share with the world. I can build pods, services out of off-the-shelf containers, out of Docker Hub or wherever the heck. My sample actually has both a Microsoft provided container and then out of the Docker Hub and a built container. So two key components. I'm using the AZ CLI, again, as we said, Azure Kubernetes services, and off we go. And then to do a deployment, I'll just do a simple deployment to the cloud and hand it over to you, Joseph. Kube control. Some people say kube cuddle. I say kube control because I'm not a cool kid. Is the command line which wraps the Kubernetes API, which lets you operate, manipulate, and et cetera, API. Microsoft has, if you go through their demos and their walkthroughs, they have a Azure Vote sample app. And that is what I'm displaying here. So if I do kube control, I've already deployed, so I'm going to do kube control get node. And this is actually from my local machine going over the network to Azure and hitting the API, the Kubernetes API provided by my cluster. And I can see that there's one machine in my node pool, and notice this VMSS. This is implemented with a Azure VM scale set. There happens to be one. I can provision more with a couple clicks of a button, or actually with Kubernetes commands, I could spin up more. I can also do get pods, and this is going to show me all the pods that I have running in my cluster. I just have, in addition to all the Kubernetes pods that are running, I have a vote front, vote back. Vote front is the front end API. Vote back is the back end, which is just a front end web interface. Back is the back end API, which fronts a Redis cache. And if I do get service, I can see services that are running. These are services that are running in what's called the default namespace. You can segment your pods and your services based on the application functions and segment roles and rights and et cetera. I'm using default cluster. So I have services, and again, what we didn't talk about in Kubernetes is a service discovery mechanism. So I have a service discovery mechanism which identifies all the services that you're running in your cluster, and you just need to know what those services are by name. You don't have to need to know exactly where they are or exactly how they're deployed, how they're built up. So I can refer to Azure Vote Back by its name, Azure Vote Back, and Kubernetes is going to route me or just discover that service by IP. I don't have to know what the IP is. It can change. I don't care. I can refer to Azure Vote Back. I also have Azure Vote Front. It happens to be have a service type of load balancer, which means I'm going to be able to load balance nodes on my front end. I won't be able to do that on my back end so easily. It's possible, but not directly available. And then I've got a public IP. Again, we can do DNS, public DNS. We can do certs, et cetera. All that's doable. That's not topic of tonight's discussion. And I have a sample of this running. So that IP address, 20.190.15, you see this incredibly sophisticated app running on that public IP address. It's only HTTP, not HTTPS, so off we go. So you ready to? Yeah, it does not have SignalR and real-time updates.
We got about 30 cats now.
Do we? I'll have to reload. I'm gonna end up with 31 because it's gonna say resend my bad. I need more dogs, man. All right. So anyway, so that's a quick deployment, and I think because you're gonna walk through your process. No, I'll just pick up where you left off. So go for it.
All right, go ahead and share my screen. You see it? All right, you guys should be able to see my screen. So I'm going to pick up back in, what month is it? July, so June, April, May. Back in May for the Python user group, I talked about using a module called Fast API, just like an API framework. And I had built some Docker containers for that presentation. So I'm reusing some of that example code in my example Docker file, and now we're going to Kuberneteify it, or whatever the verb of that is. So I'm just going to show
for me
how to run, how to get from basically I have a Docker file over to I'm running my container in Kubernetes using, in this case, Docker for Windows. I think there's a Docker for Mac too, and I think they both come with Kubernetes built in. If you do have Docker for Windows, you'll want to make sure you have Kubernetes enabled. I think by default it's not enabled, so you just go to the settings, you'll enable Kubernetes, and then go ahead and restart, and you'll be good to go after a minute. So assuming you've done that, clear that out. Something you're also going to want to do is, well, yeah, I think you have to do it, is you're going to want to create a container registry, which I already actually have running. Docker container ls. Oh, I have a lot running. Oh my gosh, didn't realize I had that much running. Somewhere in here is a container registry. There it is. So on my local machine, I have a registry where I can, kind of like Phil was saying, store my own containers that aren't on Docker Hub or aren't public. They're just on my machine in this case. So first thing we're going to do is we're just at the root of my project, and I'm going to go ahead and build my Docker file, and I'm going to tag it. I built one before using, I think, PyExample, but I'll use something, well, I'll just use that again, but we'll give it with a new tag, version 3. And then go ahead and build that. All right, you can see it built a Docker image, PyExample version 3. There it is. I'll clear it. And then what I'm going to do is tag the image now that I just created. So that's the image I just created, and now I'm going to tag it with the local registry. PyExample v3. Cool. Now I should see a, let's see, somewhere in here, a local host PyExample v3. There it is. Cool. I'll clear that out. And then I'm going to want to push that to my local registry. So I'll just do Docker push, and then that same tag I just created, localhost on the port 5000. And what was it, PyExample? All right, so it's, I think, the same as version 2, or maybe only one difference. So it goes pretty quick because it caches layers. So now we have, at this point, a new container in our container registry, and I want to deploy that container to Kubernetes. I'm going to go over to my Kubernetes YAML file. I won't go super in depth with what all is in here, but this is, I think I pulled this example as a starting point from, there's a fast API Kubernetes example, which we can include in the link after the meetup. And so all I'm defining here is a load balancer, which is basically just like a public access to my Kubernetes cluster or node. And then I'm defining, kind of similar to a Docker compose file, I'm just defining some properties of my node here. Not node.
Container or
Container.
pod.
That's it. That's where I was looking.
Right, it's specifically, it's a deployment, and your deployment could be, many multiple pods, multiple containers in the pod. So here it's, notice line 30, you've got containers : and then you would, if you had more than one container in your deployment, you'd add more containers.
Gotcha. So the line we're interested in updating here, as you can see, I was previously using version 2 of the PyExample container in my registry. So now I'm going to go ahead and update that to version 3. And then using the kube cuddle, I'm just kidding, kube control, I'll go ahead and apply those changes. YAML. So you can see my service was the same, but it did update the PyExample pod. Looks like, let's see here. I always want to see describe.
Yeah, describe.
Describe. I think that's the one. So I'll take a look at the pod, see what's going on. Looks like it's not able to find the image.
Yeah, I think there was I wasn't quite following, but I saw maybe a colon in one place and not a colon in another place.
Oh, you're probably right. You're probably right.
But if you go back there, what's interesting about that is, again, it's giving you some detail on that deployment, some logs that, that you can see. So you're not, there's some nice visibility into what's going on.
Yeah, let me I won't get too stuck in the weeds here, but, oh, yeah, so I didn't tag it with the version 3 when I pushed it. Or when I tagged it, I forgot the version 3, so let's just tag it one more time real quick. Pi example v3, local host, port 5000, pi example version 3. Push it. And reapply it. Oh. So this is where we were talking beforehand, where I was asking about the rollout.
So try killing the pod. Deleting the pod.
So then it should get restarted automatically.
Yep.
Take a look at it. Oh.
Yeah, it gets a new name.
Killed that one.
You're not going to be happy with the V.
Oh,
I actually have an alias that's K.
I saw that. I was like, is that built in or?
No.
Okay, there we go. When you actually type things correctly, looks like it successfully pulled the image from my local registry and it started up the container. I think last command, no, not Docker, kube control. We're gonna set up port forwarding, which basically exposes the pod's port to the local machine.
Yep.
Let me look at my notes real quick, because I can't remember the exact. I'm gonna cheat here and go copy and paste the command.
Absolutely.
All right, everything's working, awesome. Otherwise I'd throw an error, so we can see local machine, port 8080. And if I go there, 8080. Look at that.
Woohoo.
Hello, Kubernetes. Beautiful.
Rock.
Oh, that I already had it pulled up.
High five.
Yeah, that's the Kubernetes part. The rest is just the application itself. But you can see here, I'm able to go access it using my super secure username and password, get back obviously very super secure token. Over here, I can use that token to not do anything, I guess. Oh well, you can see if this guy's working. It's beautiful. It's beautiful.
Awesome.
All right, Phil. Unless there's any questions, I'll turn it back over to you. But that's kind of a quick run through on if you want to just play around with Kubernetes on your local machine, how to get started relatively easily.
Yeah, it's pretty easy. You have containers. It's a small matter of creating the deployment manifest to get yourself rolling. All right, and I will reshare. Okay, so we have this, my app running in Kubernetes, example of the step-by-step. Deploying to AKS is effectively the same thing. In the case of Kubernetes, what I'll need to do is download a kubeconfig file, which is done with this AKS, AKS get credentials. When I download that kube config, I now have a local cluster definition, which includes certs and keys that will allow me to run my kube control command against Kubernetes. So with Joseph, he didn't have to do that because it's running on his local machine. When I do that, again, I can execute this command And it's going to, re-download the same context that I've got. Once I do that, I can now do things like my, again, K get pods. And again, I can do the same thing here. I can do a K delete pod, and Kubernetes will take care of firing it up for me. And God willing, of course, given what happened today. No, I'm not sure of anything anymore. So yeah, that was quick. Didn't take long. Did it actually delete? Yeah, it deleted. It's got a different name. Yep. So nice, rock and roll. Abuse your containers. Abuse your pods.
Delete the pod, brings it back.
Keeps coming back. Can't get rid of them.
It's like a jelly of the month club. It
Just keeps coming back. Yes. All right. So what else? Anything else here? So I could do scale locally. I can also specify scale at the server side. There are some other scale options that, again, given time and et cetera, I'm going to leave it for today. The other thing I wanted to do just briefly was deploy via a pipeline, via GitHub Actions. So what I can do here is go into my code. Again, this is just sample code. I can go onto the voting app itself, drop down here, and probably grab out of the, maybe I'll do this.
You could add an emoji to your index.
Yeah, no, I'm not doing that, man. No emojis.
No emojis.
Not today.
A nice whale.
Let's see, what do we want to do here? We want to, come on. How did that look?
It's pretty good.
Is my code okay?
Could use an emoji.
Paired code. I don't want emojis. Can I do a dog emoji? Can you give me a dog emoji really quick?
Yeah, press
If you can do it in 3 seconds.
Win period and type in dog.
Well, now you're just embarrassing me. Win period. Dog.
And then press enter.
Enter. I don't even know what it's doing, man. I don't think I have your extension. All right, sorry.
Moving on.
Moving on. Okay, so I made a quick little change here. Not to try and influence voting or anything, but hey, got to do what you can. Dogs, proc, save all and commit. Sure, what could possibly go wrong? I'm sure I didn't fumble finger or fat type anything that could possibly screw this up, right? And if I do control GP, because I have that, I want to go there. And what this is going to do is push to my remote, which will kick off an action. And what we can do is take a quick look at that. So what I have here is this guy. So my deployment file is almost just like Joseph's. With the addition of, I have an additional deployment, additional app deployment for Azure Vote Front, Azure Vote Back, excuse me. I'm giving it a label to name it. Node Selector, which I thought I deleted because that isn't really, it's not matching anything, but this would be where, if you had GPUs that you wanted, you could label your nodes, specify that you want that label in your node selection so that Kubernetes will deploy out to that set of nodes. You can see that I'm just grabbing a standard container out of the Microsoft registry, not out of my registry, giving it port and calling it Redis. And then I have a service, which is just saying, hey, expose the service with a port, nothing else special about it. Doesn't have to be exposed externally. And then in the second deployment here, I have my Azure Vote Front. I'm saying, one, maybe for grins. Hello. My screen share just stopped. That's not fair. What is going on, man?
You've been hacked.
Somebody took away my screen. All right, we'll just keep going on one screen. I don't need two screens. I will need it to stop freaking out though. I need more CPU or RAM or something. Come on, man. You still see, you see VS Code.
I can see VS Code.
I don't see VS Code. So actually go to the YAML, which is Azure Vote on Redis, that guy right there, scroll down. We have a container demo, if you highlight line 58, I think that is, that guy right there, that's the container image coming out of my registry. So one coming out of Docker Hub, another coming out of my registry. And if you scroll down further, there's a second service there, which is saying a type of load balancer, port 80. So this is going to tell AKS load balance my stuff and expose it on port 80. Okay, and then you see env, that's passing environment variables into my app, which is telling it, hey, where's your Redis? What's your Redis called? Your Redis is called Azure Vote Back. So that's how it looks up Azure Vote Back and gets the IP address and can talk to the back end to keep track of all the votes for dogs and cats.
And cats.
And cats, fine.
Should we look at the action?
Before we look at to see what it does, let's just take a look at the workflow itself. Go there. So this is just a GitHub action, and what it's doing is logging in to Azure. It is then building an image and pushing it to ACR, similar to what Joseph did, except for parameters a little different because it's going to my demo ACR 1507-2021. Container registry names have to be unique. Just saying. And then I push, I tag it. It's tagged when it's built with the -t tag with the container registry name, and then pushes. I'm getting a version label with just using the GitHub SHA key so that every time I push, I'm getting a unique image. We then grab the kube config, which that same AKS get credential that downloads a kube config file with all the secrets in it. I have pushed that into or set up a GitHub secret with that kube config value, so my action knows how to talk to and deploy to Kubernetes. So it's just a secret that's deployed there. I can do this with service principals as well. 6 of one, half dozen of the other, or some such. We talked about namespaces, so this is a templated. I didn't write this from scratch. I used a sample, which if I wanted to deploy this to a different namespace, I could. I'm just going to the default. I then grab secrets from the registry because that's going to be needed to pull my container out of my ACR. The GitHub action doesn't have authority to pull out of my ACR unless I tell it how to, and that's what's done in that action starting at line 39. Get me a secret that I can pass on and use in my deployment. So again, Azure/K8s, this is a standard action. developed by Microsoft to make it easy to deploy to Kubernetes. And then the last line is actually the deployment to the cluster itself. So I'm telling it, hey, use my manifest. That's the same manifest I use to deploy locally to the cluster. I could, and again, with changes, use that same manifest to deploy to other clusters, assuming container registries and all that sort of stuff, but there's really nothing special about it because it's going to AKS. It then substitutes my image name with the image name I just gave it, which is all the same stuff except for that unique SHA for this particular deployment. And then again, using the Docker auth secret. So now let's navigate over to the action, just verify that it ran. I see the dogs rock there. We see, yeah, dogs rock, woohoo. I can't wait till I get to this. I'm so excited to see the website. And this is just the log of all the actions that I just said, log in, build the image, deploy the image. Okay, I'll clean up the stuff afterwards. Okay, so now you're going to want to go to IP address. I think you were already there, man. Didn't you already go there?
Perhaps I did.
Vote for cat. Don't vote for dogs, of course, because you wouldn't think of voting for cats. 20.190.
Look at that.
Dogs rock. Vote for dogs.
It's magic. It's better. It's Kubernetes.
And then let's do a K get pods. Only one running. Oh, we didn't. Did we push my change with two? Quickly go back to the. I just on my machine, which you can't see, of course, because Teams. When in doubt, blame Teams. That's all there is to it. Earlier we blamed Kubernetes crashing, but hey, whatever.
What are we looking for?
Go to the repo code. Go to the manifest, Azure vote all-in-one, Redis.yaml. And replica, that's the back. We want front to be replicas 1. So we could modify replicas to be 3 or whatever, and we would see multiple front end pods to handle the massive scale that's going to hit this voting app, right? Of people voting for dogs. So anyway.
Well, feels about like a good place to wrap it up.
That's good enough. 7:19. That's about the right time.
Before GitHub crashes too.
Yeah, and that's probably not. I mean, you could pull up the PowerPoint if you wanted. But I'm just going to talk to a few things. If you want, it's in the Meetup directory, but don't worry about it. We don't have to. You don't need the PowerPoint. So we showed deploying from the command line. Friends don't let friends deploy from desktop. So, use that for testing and that sort of thing, but, certainly not for production. We showed deploying from a pipeline. This is a relatively simple deployment, a couple of containers, using GitHub Actions. There's another technology out there, Helm. You may have heard of it, you may not. I'll make sure that in the post Meetup stuff, you get a link, but if you just search for Kubernetes Helm, this is basically a better way than that YAML file can get pretty extensive and fairly nasty to manage in more complex deployments. So what Helm lets you do is basically a package. It's just self-described as a package manager for Kubernetes. So as things get more complex, you're pulling multiple different containers into your solution. We didn't talk about certificates, but there's a certificate service, other monitoring services, things that you don't have to build yourself, Istio, et cetera. You can pull these things in more easily and manage them more easily with Helm. And then there's also a thing called GitOps, which has been around a while. A good example of that is a thing called Flux. Again, I've got a link. We pushed to the cluster with GitOps. What you're doing basically is adding a service to the cluster to pull whenever my repo, watch the repo. When the repo changes, pull the stuff into the cluster. So I just push I don't have to worry. There's still, some pipeline stuff that happens, but basically it's a pull stuff in versus push stuff out. To help facilitate the flow and enable some additional scenarios. And then there's a whole bunch of other topics for Kubernetes, many of which we talked about. So, I mean, we could talk about Kubernetes probably for the next 12 meetups if we wanted to. So, and toward that end, if there's particular scenarios, things that you're curious about, let's talk and figure out who wants to present, and we can, go for it. I've got a bunch of references. There's some interesting backstory on Kubernetes, won the war. Again, people may not remember this, but several years ago, not that long ago, there was a bunch of different container orchestration technologies that were out there that were competing, as it were. Apache Mesos, which you may have heard of, Docker Swarm, and we talked about Service Fabric, which isn't necessarily a container orchestrator. It's going after the same problem. It now has container orchestration features, but that's not the primary thing that it does. And then there's a couple of good, very good YouTube series if you're just getting up to speed on Kubernetes. Fairly short snippets. I think there might be 10 or 12, built by Brandon Burns, and he describes all the different components of Kubernetes in detail.
The creator.
I'm sorry?
The creator of Kubernetes.
The creator of Kubernetes, yeah. He's got basics, how it works, et cetera. It's, he does a really nice job. There's a whole bunch of other people, but I would just go to the source on YouTube doing videos to complete that sentence. Things that we've got upcoming for meetups, always are looking for people who are interested, what you're interested in, what topics you're interested in. I have a commitment from Josh Smith, who runs the local data SQL Server users group. He's got a really nice presentation on database DevOps, or doing DevOps with databases, both some background and sort of the state of the state with database DevOps, and then some nice examples using TeamCity. So, completely different technology, not GitHub Actions. It's got some nice features, so it's a nice presentation. So I'm trying to get him queued up. He was going to be the prior one, out of town. Was going to be this one. Something else happened, so we'll get him going for the next one, hopefully. We also have an emerging topic on service principals and app service authorization. I've done a couple of presentations on this, and then another team member, Meg, has spent some time deploying app services with integrated, AD integrated. So if that's an topic you're interested in, let us know. And then, Kubernetes, like I said, we could do more and more on Kubernetes. So
Thanks, everyone.
thanks, really appreciate it. We'll talk to you.